Just looking through the room here, it may look a little empty to you, but you are the biggest you're the biggest group I've ever given this talk to, so congratulations. Very excited about this. So my talk today is on a Python library I wrote called octothorpe. That is itself a little bit of an in-joke. It primarily controls Asterisk, which is a Linux-based, well, it's Unix-based, but it really runs primarily on Linux. Doesn't really run anywhere else. Library for handling telephony, so SIP phones, analog phones, you name it. If it involves a phone, Asterisk can deal with it. Octothorpe, an asterisk is, you guys all know what an asterisk is, obviously. Octothorpe is the little pound key on the right side of the keypad. So, it's a dumb little joke that only telephony people laugh at. I see one laughing, so we got a good audience here. My name is Matt Behrens. I'm from Grand Rapids, Michigan. I've been a developer for over 3 decades now, which seems like an awfully long time. 1.5 of those decades on Python. I've been a Unix and Linux fan since the mid-90s, and the past few years I spent developing telephony and communication software for Linux. I'm actually on my way out from that job now, so in a week or two, who knows what happens to this. But in the meantime, hey, it's pretty fun stuff. And I'm still kind of interested in it. Someday I want to get this thing to answer my phone at home, screen my calls for me. I'll give you a little background on the Asterisk platform. Like I said, it runs on Unix platforms, but mostly Linux. You're going to run into serious trouble trying to run it anywhere else. The last time I tried to build it on my Mac, it started and just deadlocked immediately. So I'm like, you know what? Not going to screw with this. It provides an abstraction to various telephony technologies. I mentioned SIP. This is a SIP desk phone here. It takes a network connection. SIP is the signaling. RTP is the audio stream that goes back and forth. It all works over the internet, Ethernet, you name it. So this is an entirely software-based telephone here. Asterisk has something called DOTI for driving analog and digital communication, so even your ancient phone lines or T1s or whatever, Asterisk can deal with. There's a number of other telephony technologies, some esoteric channel drivers, which you can use. I found them to be in various states of maintenance, so if you've got a really weird telephony thing, you might be on your own there. How to get Asterisk? Asterisk.org/downloads. It's got source code. They've got a Linux distribution you can install on your own system. What I actually typically do is add my own packages to a Red Hat or CentOS installation. They have a very nice package repository. I have some lines in my Ansible playbooks that just add stuff out, and I can build out test boxes that way very, very easily, very nicely. Almost all the Asterisk configuration lives in the etc asterisk directory. The most important file in there is called extensions.conf. It holds what's called the Dialplan. This is Asterisk's own internal scripting language. The Dialplan is required. You're not going to get much done without it, but it's very limited in capability. It's almost like shell scripting your telephones. There's no threading, there's no concurrency, there's no way to communicate between different calls that are going on. But here's a brief example. This is actually from the octothorpe distribution. This is the sample file that gets run if you decide to fire up the virtual machine. It has 2 extensions in it. If you are to pick up a phone that lands in this default context, like that one right there, and you dial 401, it'll run through this, it'll play back some silence. Allison Smith, I believe it was, who does a bunch of voices for Asterisk, she says, "Hello world," silence 1, and it hangs up again. Here's a slightly more complicated one for if you dial 402. So it'll play the silence again. It's going to connect you to another SIP extension, 202. Then once that call is finished, because this is all single-threaded, wait for each process to finish before you go to the next one, play silence again. And I left off the hang-up. That's not always a good thing. Sometimes it cleans up nicely, sometimes it doesn't. One very important concept you're going to need to understand is the concept of a channel. When you have a phone call, you actually have 2 channels. One is from your phone to Asterisk, one is from Asterisk to the other phone. Or it might be from Asterisk to the phone company. So any phone call involves 2 channels. However, You can have just one channel up if you're just interacting with Asterisk. If Asterisk is saying hello world at you, there's only one channel involved because you're not actually connecting anywhere else. It's just you and Asterisk, one channel. Yep, I covered that. So, development options. Obviously, we covered the Dialplan a minute ago, just briefly. Hang on a minute, let me mute that. You don't want to hear my tweets getting favorited all through this talk. Sorry about that. Yeah, so the Dialplan is pretty straightforward. Like I said, it's like shell scripting for the telephone. It's not very useful for more than some pretty simple stuff. That said, some people do a lot of stuff in it. The primary development method for Asterisk for a long time was modules. So loadable extension modules written in C. So I can tell you guys are I'm already losing you here, and that's fine because this lost me too. When I saw it, I'm like, I'm not writing these things just for the simplest of applications. Digium, the people who make Asterisk, believe they're subject to the GPL, which can be a deal breaker for some people. They are the most flexible option because you have access to everything. And most of Asterisk's core functionality, it ships with some voicemail, some other things, is implemented in extension modules that are shipped with Asterisk. But it's primarily for adding new functionality that does not currently exist. So the first thing that came up was the Asterisk Gateway Interface, AGI. In the Dialplan, you, like one of those lines that said playback or whatever, we have what's called an AGI call, which is another application run. We spawn an external process or connect to a listening socket somewhere. And you can write these AGI applications in any language, including Python, that can handle standard in, standard out if it's in a process, external Asterisk, or you can do sockets. So, if you can even send them off to a remote server if you wish. Some people do the socket thing so they can do everything in one process. Limitations for AGI, there's one AGI session per call. There's no cross-channel state unless you're building out a crazy server that accepts lots of these connections, or server awareness. So while you're in an AGI call, you don't get an understanding of what's going on in the server. Like if a phone's up or monitoring other calls, that sort of thing. Command set in AGI is really targeted towards user interaction. It's similar to Dialplan, but better. So the other key way of developing for Asterisk is called the Asterisk Manager Interface, AMI. A client connects to Asterisk on the AMI ports 5038. Not that you'll need to remember that. All global events immediately, once you've signed in, on the Asterisk system are started to be sent to the AMI client. It's just kind of a little fire hose there. You get to see everything that's going on. Phone registrations, calls being initiated, Dialplan being executed. And then while you're listening to that, you can also issue what are called actions. So they're pretty much context-free. All the parameters are carried in an action. I'll show you them in just a minute here. And Asterisk will issue responses to the actions you issue. Now, the AMI command set is targeted towards managing the whole server. So you can see there's a little bit of a mismatch from what you get with AGI, which is really targeted towards driving one call. So they're two separate worlds, if you will. Here's just a little example of some AMI traffic. Right here is an action that a client is sending right away just to log in. This is a real simple login. There's more secure ways of logging in than just sending your password in the clear, obviously. They got a response back, says success, hey, we love you, and it starts sending events. This guy here says a phone just registered. This guy here says, this guy here said a phone is unregistered. This one says he's registered. And this new channel one is a call being initiated. SIP201 is the phone that's doing it. Says he's dialing 401 down here. So the question becomes, for your application, which one of these two are you going to choose? They're two different worlds. The great news is there is a way to bridge them both. It's called AsyncAGI. Marries the worlds of AGI and AMI together. A Dialplan AGI call to a special target called AGI Async will make Asterisk emit an AMI event called an AsyncAGI event, and it'll just sit there and wait for the AMI client to take over the call. So it's like an AGI session has begun. Actually, an AGI session has actually begun, but there's no socket connection made or external program run. The AMI client sends AGI commands as AMI actions. Everything continues to run over the one socket So, it's really great for if you have one program that needs to cover global state of the system, understanding all the calls that are flying around, all that kind of stuff. But the one thing you need is a really good way to demultiplex all this stuff that's flying over the line. So I turned to Twisted for this. Twisted, for those who don't know, has anybody here done Twisted at all? One? Not too bad. I was sitting through Brian's talk earlier on AsyncAGI, and he was talking about how much effort it was, because so many people who aren't from the async world, the concepts are a little foreign to them. So I hope I don't blow anybody away here. I'm going to try to keep it pretty simple with this library, and the library's intent is to keep it kind of simple. But Twist has been around since 2002. I still remember when they were kind of start getting it off the ground. It includes a lot of common protocols. There's Telnet, there's web servers, web clients, XML RPC, which I don't know if anybody here even knows what XML RPC is anymore. I see that grin again, I used it in a project the other day. It was just simple, so I just used it. But the one with the really key thing about Twisted for me is it's easy to move between the callback driven, meaning you've got objects out there that are going to receive callbacks that say, hey, this hung up, hey, this is dialing, those sorts of callbacks, and what's called an inline callback style, which lets you take a whole call and kind of flatten it into one method call, and I'll show you an example of that in a little bit here. Some quick Twisted terminology. The reactor is supplied by Twisted. Its job is just to manage everything. It calls all your callbacks and methods whenever there's data or events happening. Deferreds are a fun concept. When a function returns, because it's asynchronous, it has to return control and let other network connections work, do their magic. It returns a special object called a deferred, or a promise for JavaScript people may be able to follow this one. It's a very similar concept. When a result is not immediately available, the person receiving the function receiving the deferred attaches callbacks to it that are called when that result becomes available. Airbacks handle exceptions that would occur during that processing. One of the really neat things about the way Twisted handles it, it's got something called deferred chaining. So if I had a function and it returned a deferred because the result wasn't available yet, and then its callback itself returned a deferred, and if these things stacked up and stacked up and stacked up, the stack itself would blow up. But Twisted actually optimizes these away, so you can effectively infinitely chain these together, and this is used pretty extensively in Octothorpe itself. I think I turned my Wi-Fi off. Let me see if I can get an example here up for you. Oh no, I got back on. Okay. Hang on a minute. Get the browser over there. So this is an example from the code here. This is, remember I told you there's a better way to log in than just sending usernames and passwords and clear text over the network. This uses an MD5 challenge response protocol. The send action returns a deferred itself, and when Asterisk has responded to that challenge, it needs to. I'm sorry, I got that backwards. When Asterisk responds to the action, my code needs to respond to the login challenge and complete the login, so it returns another deferred. So it's going to stack and flow through those, and I'll show you how that gets used in a few here. I know I keep saying I'm going to show you how this gets used in a minute here, but we'll get there, I promise. Octothorpe is so the library I developed to control Asterisk using Twisted. It's an AMI protocol implementation. It's got a couple key classes here. If your application only needs AMI, i.e. you're only monitoring what's going on in the system, you're not really interacting with it, except for a few key kind of global actions, you can just use the AMI protocol, which is pretty simple. All it does is issue callbacks when events happen in the system. When channels come up, you remember channels between a phone and Asterisk. Whenever those come up, a new channel object is spawned. You can provide a class for these channel objects, so they have all your own logic in them. And it'll route events appropriately between the channels, so you don't have to manage the channels. This is actually a really big deal for writing AMI applications, is trying to figure out where all of your different events are supposed to go, keeping that logic straight. So one of the primary goals of Octothorpe was to really smooth that out, and I think it's done a pretty admirable job of it. And then it uses deferreds extensively itself to turn the actions and responses into function calls. So that is the overview, and now I just want to show you guys, unless you got any questions right now. I know it's a lot to think about right now, but I have a few demos here. If you guys have your laptops out, if you folks have your laptops out, you can go to my GitHub and check it out. All the demos I'm going to be showing you today are in doc/examples, so you can browse through them. If you happen to have a Vagrant box, this specific Vagrant box recently, you can Vagrant up in there and you get a ready to go Asterisk system that's all ready to run these demos. So I doubt that applies to anyone, but I figured I'd mention it just in case. The setup I've got here, remember I mentioned Digium's RPM repositories. They're running inside a CentOS 6 virtual machine. There's some very minimal Asterisk configurations. These are all in that GitHub repository in Etsy Asterisk. I have two phones. I have telephone.app from the Mac App Store. It's a freebie. It's connected via a host-only network to the virtual machine as extension 201. And I have this little guy, a Digium D40. Digium's bottom-of-the-line SIP phone, which they gave me for free when I studied in their training course. I suppose I have to give it back now. To my company. This is connected as extension 202, or it would be if I actually plugged it in, so that's why my virtual machine wasn't starting up. Let me just finish that real quick a minute. The Dialplan that's used in these, it's in that same repository, Etsy Asterisk extensions.conf. There's 3 extensions that are important for this. 401 is just, 401 and 402 you guys actually saw already. There's a hello world speaking one, and then there's one that actually dials from one phone to another. 403 is going to be the important one because that one puts us into AsyncAGI mode so that our twisted application, our Octothorpe application, can take over. So I'm going to go ahead and jump out of the presentation here and just quit that for now. Hang on, let me restart this with the... Yeah, you don't need to clean up. You didn't do anything. Now that I actually have this connected, it should come up fine. Oh, and I need to boot the phone too. This will take a couple minutes. Quite literally though, if you already have that box downloaded, this is all you have to do. I spent some time doing that because I really wanted to smooth the whole path in case anybody wanted to try this out. It's almost there. There we go. While we're here, we can look at the Asterisk console, which you type that R asterisk dash VVV there, it will put it into verbose level 3 so you can watch things that are happening on your different phones. Phone's still booting. Telephone. As you can see down here, it said that phone is now registered. This one is almost done. This has the slowest firmware image I've ever seen. Start. Please be patient, it says. There we go. And we should see a registration message here. Unless it thinks it's already registered. Well, let's give it a shot. If you guys remember extension 402, which I'll go ahead and dial in here, should ring this phone if this is working. Hello. This is one of the fun things you get to do if you're in a shop where you're developing telephony applications, especially if you got speaker phones like we do. You have your phone ringing and you pick it up and you very rapidly reach for every mute button you can possibly reach because you're going to create a feedback loop. very quickly, especially the ones with public address. We sell phones with public address attachments on top. You call into them, and they route their audio up to this gigantic 360-degree speaker. I am going deaf. And I don't know if I should be filing for workman's comp or what here, but it's probably my own fault, so I don't think I'd have much of a case. So that just checking that one out there. So we've got, go ahead and close this. I'll just open another window here. Now I'm going to be running all these octothorpe demos from my Mac. So even though I've got a Linux virtual machine there running Asterisk, connecting to the phones, talking to the phones, all the demos are actually running on my Mac and a Python interpreter on my Mac. So just to show you, with this whole AMI thing, you can certainly control Asterisk running in one place from a master controller. You could even theoretically control multiple Asterisks if you needed a scalability solution. There, because Asterisk since it's handling all the media flowing through it generally, doesn't scale quite as well as you'd hope it would sometimes. All right, so our first one we're going to look at here, let me just go ahead and make this one bigger here. Can everybody see that text okay? Because there's going to be a lot of text, so I don't want to make the letters much bigger. Get into my virtual env here, and then doc examples AMI watch. If you remember the AMI slide, the first thing we saw was that fully booted event, which is basically Asterisk saying, hey, I'm ready to deal with you now, AMI client. Oh, and there's a registration message that came across. Just to kind of give you an idea of how much goes across this interface, this is going to show everything that's going across the AMI interface. We'll go ahead and go back to our telephone here and just repeat that let's do a hello world call actually. So that'll be the simplest one I can possibly do.
Hello world.
Okay, hangs up. There's all kinds of stuff here that flies just for that one call. Yeah, so part of developing this sort of stuff is learning to discern which of the events are actually important. But there's also a lot of convenience in octothorpe. Like, for example, here's the new channel. When octothorpe sees this new channel, its default action is to go ahead and spawn a new channel object and then call a method on it to indicate that, hey, a new channel is started, you can start to control it. Var sets is another convenience thing. A lot of actions in Asterisk set a variable on the channel. It's basically a key value store for every channel. octothorpe will keep track of these for you, so you don't have to sit there and watch for the var set events yourself. There's just a dictionary you can query at any time.
And that's per channel?
Yes. Yep, that's per channel, yep. State, we get state changes when it's ringing. And up down here is when it's answered. There's another new state there. New extend is sent. It's kind of a really wackily named event there, but basically that means it's moving through the dial plan. So you'll see a new extend every time it goes one line through the dial plan. Some RTCP reports for the truly hardcore, so you can tell how your RTP session is going. And here it is, hitting that playback application that we saw before. And it tells it to play 3 sound files. There's a 1-second sound, silent sound file, the hello world, one more. There's another variable set saying, hey, success, it played sound. And then it gets to the hang up part. So there's some teardown involved there. And then that's it. So that was just a real simple example. I closed that window, sorry. Let's go back there a minute. Doc. Oh, I guess I could just look at it in Vim too, couldn't I? Sorry. Literally, this is the entire implementation of that right here. Banner received is a callback that happens when it gets I don't know if you guys have ever telnetted into different protocols. You get the banner which says, hey, I am a this. Talk to me. This is called when it receives that, and it'll tell you the version of Asterisk you're dealing with. So my reaction to that is to log in. And then from then on, whenever I get the event received callback, I'll just print it out, which Twisted intercepts and turns into log messages for me. So print is very convenient in that respect. We have one more kind of watch things demo here, which is called Chan Watch. This illustrates the channel objects that get spawned whenever there's a new channel. So this is our AMI protocol subclass here. This looks not very different from our previous one. The difference is that there's a new channel callback here that octothorpe's going to take care of when there's a new channel. It's going to tell you its name and any parameters that were used to spawn it, and also pass you an instance of the channel object. The channel object itself, because there's a channel class on the protocol class that we can use, is where we put our implementation of what we actually want to do with each channel. So they're handled independently. We get a brand new object for every channel. We're watching for a few different events that happen here, like the variable set that we saw. I don't know why renamed in there. Is that something you never see in this particular context, but it's there anyway. I was testing it once, sorry. Extension entered is when it's going through the Dialplan. So this is going to look a little different, but we're going to go ahead and repeat the same thing, same experiment again. I could do it with the phone too. Why don't I just do that? Speaker.
Hello, world.
As you can see, these variables are really stacking up here. There's a lot available, but octothorpe's keeping track of them for you, so as you go through. But here you can see it walking through the Dialplan. There's a couple different things. It's the same thing we saw before, only kind of starting to show you how octothorpe will make your job easier dealing with all the stuff that's flying across the line there. And the really important part of it is you don't have to pay attention to all of this stuff to do useful things, but just kind of give you an illustration of the kind of things that are available to you. The next thing I'm going to do is actually start to have it actually do some interesting things, and that's a program called AGI Hello. This is Hello World, only implemented through AsyncAGI. Now, we went ahead and we set up extension 403 that's going to transfer control to our script. I think I can actually, let me show you that to you real quick. It's right here down at the bottom. All it does is do this AGI called AGI async, which emits the event that our program picks up on, and then we hang up and we're done. So what we've got here, first of all, is our protocol. You notice we're using the AsyncAGI protocol now instead of just the AMI protocol. Our channel class is going to be an answer channel, which we're implementing up above here. We got some logging stuff here, which is actually going to make it a little noisy. But all the fun action, all the fun stuff happens here. An AsyncAGI started indicates that in the Dialplan that AGI async thing was run. So it emits that event. Asterisk is transferring control to us. The first thing we do is make sure that it's actually, because as you may recall, there may be lots and lots and lots of things happening here. We want to make sure it's the one we're actually looking for. So we're going to check the context in the extension. The context is, every phone has a context, so the numbers you dial are looked up inside that context. So we're going to check that we're in the default context and that somebody actually dialed extension 403. If so, we can own that call. And the first thing we do is send a playback message via AsyncAGI here. This was actually more complicated in the last version of my talk, but I made some last minute changes last week. When this deferred calls back to playback done, I used to have to do a whole bunch of checking result codes. That is now strictly a success or failure job, and it will actually throw an exception for you if there was any problem playing back. But all we're going to do here is it's going to be hello world again, but we're going to be doing it a little differently in that we're going to control the call through our Python script entirely now. So this program right here. Except we're going to dial 403 this time.
Hello, world.
Pretty straightforward. Let's scroll through here real quick. Break it so it doesn't keep scrolling. Ooh, look at that. Huh. I guess I need another test in there for that one. I'll figure that one out later, but Here's some of the log messages that actually came from our script in between all the AMI log messages. So, okay, here we got an AsyncAGI event, which is actually this guy right here. And we check that it's in the right context, it's the right extension. It's ours, so we're going to send this playback. And once it's successful, we send the hang up action. So it's basically the same thing we've been doing. So now let's do something a little more interesting. Let's have Asterisk give us a call and tell us hello. Okay, so it's very slightly more interesting. But this is where you start to get to the power here, because initiating calls from Asterisk can be quite the interesting challenge through the provided methods. So here's our origination script here. Here's a big explanation in the doc string there, but I'll just walk you through it real quick. Once our originator gets its banner, it does a login, adds a callback to that login. When the login is complete, it calls originate AsyncAGI. This guy's job is to make a call to SIP 201, which is, actually that's my Mac, and it gives it a caller ID. And then once that is actually complete, it's going to call back through AsyncAGI started down here, which tells the brand new channel object we want to start handling the call. So with our new channel object, which is one of these guys, the originator channel, our start method, I just defined it. It can be anything, foobar. We're going to execute we're going to play back hello world again, you know, the old familiar thing. I promise the next one will not be hello world. But and then hang up when it's done. So the rest of it's actually fairly familiar, and I think I did originally copy paste this from the other script. So, that was a ridge hello, sorry. There's my Mac telephone. There's actually a pop-up over here you guys can't see. Oh yeah, answer.
Hello, world.
And there's our hello world again. So, all right, like I said, last hello world. Now we're going to do a few more, slightly more interesting things. Next one is DTMF capture. I can't read that. I got it, thank you. So DTMF capture, examples DTMF. This is going to use a routine in octothorpe to actually go ahead and listen for DTMF that comes in the line. DTMF, for those of you who maybe aren't quite as old as I am, are these number keys on here. The tones they make are called DTMF, so that's very much a telephony term, but one of the other interesting things about DTMF is completely unreliable over cell networks, over certain SIP systems. For something that's so important to telephones, you'd think they'd pass it right, but they don't. And that's one of the lessons I've learned over the past few years. So we're going to introduce something new called inline callbacks. You guys are probably getting sick of seeing all these callbacks and saying, oh, this one goes over here, and this one goes over here, and pretty soon your arms are all twisted up trying to point from one place to the other. So we use a twisted feature called inline callbacks here. What that lets us do is take all those callbacks and all those deferreds and collapse them into something that really looks kind of like a function that's going to execute all at once. But in reality, every time we hit one of these yield statements, we're passing control back to twisted. So what we're doing here is we're going to play a beep sound. But the yield actually, while this is before this guy's response comes back, we're yielding control to twisted. And Twisted's going to continue to process everything else it needs to until the response for that actually comes back. Once it does, and if it raises an exception too, it's just going to blow up because I have absolutely no exception handlers in here. But that's cool, you know. Then the next thing I'm going to do is do another yield, my capture DTMF, which is going to wait and continue to process everything else Twisted does until I've got 5 digits of DTMF here. I'm going to translate them. They normally come across as numbers. Sometimes they come across, you know, they just hit the pound key or the star key, say pound or star. I'm going to read back the digits, basically. So for each of these digits, I'm going to cue a playback command, so it's going to speak back whatever you just dialed, and then hang up at the end. Oh. Okay. Oh, I'm in the middle of the call here. So there's our beep.
1, 2, 3, 4, start.
And then it hangs up on us. So, our final example, we're going to bring all this stuff together here. We're going to create just a little interactive voice system. It doesn't do much, but it's got a passcode at the beginning. And it gives you a menu of 2 options. You can call another extension on the system, or you can finish your call. These are more commonly known as customer service torture devices. And I'm proud to say I haven't actually developed one for customer service torture. So that's not my new job either, thank goodness. So again, we're going to do an inline callbacks because now that we have this complicated logic for an interactive voice response system, we really want this to look as much like a normal Python function as we can. If we were jumping all over the place, I would not be able to follow this. And that would be a really confusing talk for the rest of you, I'm sure. So we're going to start off playing silence. It's kind of good practice because you ever pick up a phone? I don't have it to my ear immediately. So if I'm going to start talking to somebody who's picking up a phone, I want to have that second of silence there. Here we're going to ask for a password. Some of these sound file names look a little weird. Some of them come from different applications, so I've just chosen ones that sound vaguely appropriate because I wasn't really up to recording all my own IVR messages. It's going to try to capture the password, gives them up to 10 digits to try. This is the same password that's on my luggage, so I thought I could remember it fairly well. If it's not right, it'll say incorrect, loop you back. This is pretty dumb. It doesn't actually hang up on you after you try wrong too many times. It'll actually just loop on you forever. But then gives you a thank you when it's done. This is the lengthy voice IVR message it's going to play for you. What it's going to tell you is press 1 if you want to transfer your call, press 2 if you're done. Captures the menu selection. There's lots of stuff in here, you know. This actually has a little bit of interesting stuff here. I haven't abstracted this part away yet, but if I get a result code back from that dial that's a -1, I know that call failed, so I'm going to actually tell them I'm sorry, and we can continue on our way. We'll break out of this loop if they actually want to finish and play a thank you message. But otherwise, we'll tell them, hey, I didn't know what you just dialed at me, so. Okay, examples IVR. Oops, there we go. This one will be a lot easier to follow because thank you. I don't have all the logging messages that were spewing across before because that would just be impossible at this point. Okay.
Please enter your password followed by the pound key. Password incorrect.
Yep.
Please
Didn't like that very much.
followed by the pound key. Thank you. Press 1 for transfer. Please enter the number you wish to call.
So I can dial 201 here, which was my other phone.
Please hold while I try that extension.
Yep, I knew that was going to happen. I knew that was going to happen. Had the things turned up too high, I guess. And as you can see, we had an exception because of that, because I didn't write very clean code with lots of exception handlers. But we'll try that one more time without the call this time. Just let it dial through. Redial.
Please enter your password followed. Thank you. Press 1. Goodbye. Thank you.
And there's our goodbye one.
Asterisk open source PBX.
Oh, you're very welcome. All right. So, just to, there was one thing I neglected to mention there, actually. You notice I interrupted it speaking quite a few times. That is a special case of playback called background, which in our case, we don't care what they interrupted it with, but you can actually retrieve that from the callback if you actually care what digit they interrupted it with. But because DTMF is also passed as events, we don't actually have to listen to that. So that was actually the demos I had at this point. We'll get back to the... just want to talk to you real quick about some other applications I'm not going to demonstrate today. Some of them don't really look like much. Others are just really hard to do up on stage, especially with a short talk. DTMF injection was one I did, which really leverages the fact that Twisted has lots of different network supports. This was the XML RPC thing I did, actually. While calls are in progress, I can actually inject a DTMF digit into the line, which controls the speakerphones. If you dial certain numbers on the line, they can be told to raise their volume, lower their volume, turn flashing lights on and off, these sorts of things. So what this program can do is send an XML RPC call into our daemon that's handling all the call listening. That permits it, that will go ahead and inject that DTMF and control the device. And that lets us feed it all the way back to like a PC program on a desktop that lets people actually click buttons to handle all the auxiliary functions of those phones. Then the really fun one I did was something we called the emergency monkey system. We had a need to capacity test these guys. So what I did was created 100 virtual hotlines calling 100 virtual emergency agents, and just because I needed a really good sound source that I could listen to, I picked the monkey screeching sound. So literally, you know, the emergency guy starts screeching and the agent guy start screeching at each other. And in the middle, I've got this all being recorded, so I can pick up any call and just listen to how well the monkeys screeched at each other. That was a fun one. My coworkers loved listening to it too, let me tell you. So that is all I've got for you in my slide deck here, besides some further reading links if you would like to read more about Asterisk or Twisted, and hopefully you already have the link for Octothorpe. Does anybody have anything? I got about 5 minutes left to burn here. Yes? Oh, yeah, thank you. I forgot.
Do you need any special telephony hardware on your host machine where you're running Asterisk?
No, in fact, you can go ahead and just do SIP phones for everything. And you can even connect Asterisk up to a SIP telephone provider over the internet, if you wish. The hardware just comes into play if you're interfacing with different things. We actually do, at my old job, sell analog phones, speaker phones, because people really don't like to put networking stuff in the ground where they've already got perfectly good, crappy copper lines that they can hook phones up to. So they like those. But yeah, this literally is all a networking-based thing here. I bought the USB Ethernet adapter and just plugged it into the phone, and I've got a phone system already. So, anybody else? Back there? Oh.
I was wondering if you can send text messages through apps, through mobile apps.
You would have to. You would have to use a third-party service for that, I think. There is a SMS application that ships with Asterisk, which you could control with Octothorpe. However, as my understanding, it's based on some weird European standard that I don't even understand, so I have never tried it. But what you could do is, if you had a telephony you need to integrate it with, then Twisted could take care of both of those tasks for you. So, but yeah, you're probably best off looking for a third-party service for that. They will be. I'll post them tonight. My website at zig.com.
Yeah. Just trying to. This is being recorded so that on Pile High you can come back and see these entire presentations.
Yeah, that's also true. Yeah.
And that's why going through the whole thing with the mic. So some of the questions you asked, some of the others will be looking at the video. And
the question was just simply if the slides were available. Sorry about that. All right, so that's it. Anybody has anything else? Feel free to ask, but thank you.